Okay, so clockwise versus counterclockwise. So we're going to be rotating points. So rotation is a transformation that turns every point of an image through a specified angle and direction about a fixed point. So essentially, we're going to be rotating about a point. The point will be the origin or some other point on the graph. And we're going to rotate about that point. So we are either going to be rotating clockwise or counterclockwise. The center of rotation is the fixed point that you're rotating about. Okay, so the center of rotation is, like I said, either going to be the origin or some other point. And then the angle of rotation is the angle measure that the image is rotated. We're going to do standard angle measures like 90, 180, 270. I'm not going to give you angles like rotate it 73 degrees, right? You would need a protractor. So we're not doing those. We're just going to do the standard ones that we can handle. So you should all, this is how we're going to be rotating. Here's your sheet of paper. And if you want to rotate something clockwise, which way do you rotate it? If you want to rotate it counterclockwise, you rotate it that way. So if you're not very good at visualizing where these should go, you just have to be able to actually rotate your paper the correct way. Okay? So what we are going to do is we want to plot this point, negative 4, 2, and then we want to give the clockwise 90 degrees about the origin. So negative 4, 2. So 90 degrees, what does that mean? That means a right angle, so we're going right. So this is going to be easiest to do on your paper. I sadly can't rotate my whole board. So you're going to take your sheet of paper and you're going to rotate it 90 degrees. Now look at the point that it's located at now. So what's the coordinate that your new point is located at? 2, 4. So the new point was 2, 4. So now put your paper straight back up and plot the point 2, 4. There we rotated it 90 degrees about the origin. Does that make sense? If I were to draw these 2 points in going to the origin, they form a 90 degree angle. Yeah, you can, but that involves all those rules. I don't like the rules.
Wait, it's to the origin?
Yep, to the origin. So if you were to think about this going to the origin, that definitely makes a 90 degree angle. The origin is 0, 0.
So for the next one, you plot it, and then can we make them negative so it does 90 degrees? Now?
Well, so the next one now we want to go counterclockwise. So we're going to plot the point 4, 3. Okay, now if we're going counterclockwise, take your paper and turn it counterclockwise 90 degrees. So, and now figure out the new point that you have.
Negative 3, 4.
So we now have the new point is negative 3, 4. So then turn your paper the right way and plot negative 3, 4. And let's see, this one ended up being 2, 4. Do you see why I'm not saying don't exactly do the negatives? Because when you compare these two, they're not. Some are flipped and some are negative, but it's different for every angle measure. So I don't want you guys to have to memorize what happens for 90 degrees, 180, and 270. So if you just rotate your paper, you can see it.
But I kind of got it right.
Yeah, you have the right idea of how to get there. And once again, if you're looking at here, if we go to the origin, that forms a 90 degree angle. Okay, is this okay?
Yeah.
Okay, let's look at some others then. So here we want to plot the point negative 2, 5, and this time we want to go clockwise 180 degrees. So negative 2, 5 is right there. So if we want to go 180 degrees in clockwise, if your paper is starting like this, 180 degrees is
Negative
upside down.
negative 5. Oh, 2 negative 5, sorry.
Yep, and then we get 2, -5. And so then we plot the point 2, -5. And now these two, if we have 180 degrees, if we connect both of these with the origin, it should be a straight line. And that's what it is. Okay?
I got yelled at last year when I said straight line.
Well, all lines are straight,
Yeah,
but.
so it's not line, it's not straight.
Okay, plot the point -1, 7, and this time we want to go clockwise 270 degrees. So 270 degrees, how much is that? So you go, this is 90, right? Then we go 180. You have to go one more time for 270.
So 90, 80.
Yep, so 90, 80, 270, and now read your new point. Yep, so at -7, 1. So then you would plot your point.
Wouldn't it be -7, -1?
Yeah,
Okay.
Yeah, then you'd plot your point -7, -1. Well, that's kind of hard to see. But when you then connect those 2 points to the origin, and if you look at that angle is 270 degrees. The outside angle. Because we were going clockwise, so this would be our clockwise motion.
Okay, so if it's 90 degrees, you do 1 turn. If it's 180, you do 2.
270, you do 3, yep.
Is
Just-
there anything greater than 270?
No.
360.
Okay, so now we're going to rotate about a different point instead of the origin. We can do this. So what we want to do is we're going to still plot our point like we were doing. So this time our point is at -2, 4. And we want to go clockwise about the point 1, 5. So what do you think we should do with that 1, 5?
Put a different colored dot on it.
Yep. So 1, 5. So this is the point that we're rotating about, right there. So what we need to do is when we rotate our paper, we need to figure out where, with respect to this point, are we at. Okay, so like right here, with respect to my point 1, 5, I'm at -3, -1, with respect to that point. So when you rotate this clockwise 90 degrees, figure out where you are with respect to that point. Does that make sense? You would look at this point, so rotate your paper 90 degrees. Count from this point where your new dot is. So from this point when you rotated it, how did you have to go? You had to go -1 and +3 is what you should have to go from that point. So you had to go -1, +3.
Oh, to get to there.
So from this point, you have to go -1, +3. Anyone else need help seeing that? You all see that? So from that bottom point there, Jesselyn, you're going -1 and then up 3 to get to your,
So that's what we're writing down.
Yes.
We're not actually plotting.
right. Okay, so we went -1, +3. So then from when we turn our paper back up, we're going -1 and +3. That would be our rotated point right there. So we have to just go from that point.
Oh, I get it now.
Is that okay?
You can cover
Well, we don't have to connect them, but if we want to show that we have the 90 degrees there, that's our 90 degrees. Is everyone okay with how we got that one? Okay, we're going to do another one like that. So we want to plot the point 1, -3. And this time we want to go counterclockwise 270 degrees about the point -26.
You did your point wrong. You did -1, -3.
Yes, I did. Thank you. 1, -3. Let's try again. Okay, about the point -2, 6. So make sure you turn it your 3 times around.
Okay, so when we're trying to find this, like, we're going off of what point? The one that... the
You're going
second
off your
one?
second point, yep.
Okay.
So you're going off of here, you'd be counting it from this negative 26 point.
We got
3,
3, 9.
9?
3, 9. Wouldn't it be 9, 3?
That's not far.
It'd be 9, 3.
Which one would it be?
It'd be 9, 3 because you're coming from your thing up.
Oh, I did it clockwise.
Did you go clockwise and not counterclockwise?
I got negative.
Okay.
Oh, shoot, I just got
So we went,
I got negative 9, negative.
Yes, I have it.
Because don't you have to?
It's negative 3, you have to go sideways.
it's so you guys are getting negative 3, negative 9.
9, negative 3.
That's not right.
Yeah, no, you have to-
Negative 9, negative 3.
Yeah.
I
It'd
thought
be
you have to
negative
flip
9,
the
negative
paper
3.
first.
What?
How do you know
Okay.
which way to go from?
You go from the new point.
Yeah, I know, but like, you can go down or...
Well, you X first.
Yeah, do your X first and then your Y. So always go from that point that you had plotted. Yep, so right, from right here you'd go left 9 and then down 3 after
From
it's...
here we can draw our new angle.
Yep, and then from there you could draw your new angle.
So I'll go ahead.
And notice from the original to the new, we are going counterclockwise 270 degrees. Is that okay?
Yeah.
So when you're going about a different point, it gets a little tricky, but you can do it. Yeah, 9,
You'll draw.
negative 9, negative 3. That's where you had to move.
Because I thought you had to like turn the paper and then you count it from the.
Yeah, that's it, yes. Okay, so then the other thing we have to talk about is that there is something called rotational symmetry. Okay, rotational symmetry is that if a figure can be rotated less than 360 degrees, so it just means less than one full time around, about a point, its image and pre-image are indistinguishable. So here is a regular pentagon, and this is happening with the regular pentagon. So here, this regular pentagon was, oh, I drew that arrow going the wrong way. Here, this regular pentagon was first rotated to the left, right? And then rotated to the left again, because now your angle 1 is down here. Then rotated to the left again, and rotated to the left again. So do you see that? It's the same pentagon every time, but it was being rotated. Do you guys see that? So angle 1 moved from here to there, to there, to there, to there. So it's kind of like spinning along. But every image looks the exact same. That's rotational symmetry. So if you can rotate an image and have it look the exact same at any point, then it has rotational symmetry.
So an isosceles triangle.
An isosceles triangle would definitely have rotational symmetry. So would a square. A circle is infinitely many for rotational symmetry. So the order of the rotational symmetry is how many times can you move it and get the same image. So for this one, we can move it 5 times. So we would have 5 of the same image. We'll talk about that next. The magnitude is how many degrees does it move each time. So if we're going in 360 degrees and we went 5 times is how many times we could move it. Yeah, we would just have to do 360 divided by 5 here. Well, what is 360 divided by 5? Five goes into 36 7 times. You have 10 left over. 5 goes into 10. Yep, so 72. So this magnitude is 70 degrees. So what that tells us is that from this first image to the second image, it rotated 72 degrees in the counterclockwise direction because it was going counterclockwise.
Will it go counterclockwise each time? Or?
Well, no, it could go either way. We could go 72 degrees in the clockwise and get the same images. Make sense?
So, but it'd be a positive number.
Yeah, this is always positive.
Okay.
So for example, an isosceles, or not isosceles, an equilateral triangle, what would be the order of an equilateral triangle? How many different ways can you draw this? 3 different ways. So this would have an order of 3. And then the magnitude would be 360 divided by 3, which would be 120 degrees. Make sense?
See?